Okay. So in morning lecture only we have discussed that how we are going to control the presence of arsenic as an impurity in the pharmaceutical substances. So already we have discussed the principle behind this limit test. What is that actually? Conversion of arsenic impurity, that is arsenic, is based upon the reduction of arsenic into arsenic acid. Then arsenic acid is converted into arsenious acid. Arsenious acid, when reacts with an hydrogen, it is converted into an arsine gas, and this arsine gas, it will be eliminated from the reaction mixture. And how we are going to come to know that it is totally eliminated from the reaction mixture? When it is reacting with the excuse me. So how we are going to come to know that arsine gas is eliminated from the reaction mixture? When it is reacting with the uh, paper which is dipped in the mercurous chloride. So this mercurous chloride paper will turn yellow stain when it is reacting with the arsine gas. So this is a principle behind this limit test of arsenic. So we are going to prepare a test solution and standard solution. Test solution, we don't know how much amount of arsenic as an impurity is present there, but for the standard solution, we are going to add known amount of impurity. So the test solution is prepared by dissolving specific amount in water and standard hydrochloric acid, which is totally arsenic free and kept in wide mouth bottle. So this solution, 1 gram of potassium iodide. To this solution we are going to add 1 gram of potassium iodide, 5 ml of stannous chloride acid solution, and 10 gram of zinc. So this is, we have already discussed this all material we are going to fill in this apparatus. Here we are going to use one apparatus for the sample solution and another one apparatus for the test solution. So both solutions, mercurous chloride paper, we are going to compare with each other. Uh, so this apparatus is known as gadget apparatus, and the test which is carried out for the detection of arsenic impurity in the pharmaceutical substances, that test is known as gadget test. Now, what are the reasons behind why we have used stannous chloride in this reaction mixture? So the use of stannous chloride is used for the complete evolution of arsine gas. Here, stannous chloride is used as an reducing agent for the complete evolution of arsine gas. Then the addition of zinc, potassium iodide and stannous chloride, they are comparatively and they are combinedly used as an reducing agent. Hydrochloric acid is used to make the reaction mixture acidic, and lead acetate bleach or the papers are used to trap hydrogen sulfide gas, which may be evolved after the along with the arsine gas. So these are all the different significance of all those reagents which we are using during the determination of arsenic as an impurity. Now, with respect to the conclusion and observation, we are going to compare the observation produced by the test gadget apparatus and standard gadget apparatus. If the colorant intensity produced on the mercurous chloride paper, if it is less than that of standard, then our sample solution will complies or will passes the limit test of uh, arsenic. So these are all about the limit test of arsenic. After 40 minutes, if the intensity, after 40 minutes, if the intensity of this arsenic limit test or the yellow color on this mercurous chloride paper produced in the standard is more than that of test, then our sample solution will comprise the limit test of arsenic. So we have to keep it aside the mercurous chloride paper for 40 minutes as it is to do the comparative study. And if those mercurous chloride paper will retain their yellow stain, and that yellow stain on the test paper, if it is less than that of standard, then and then only our pharmaceutical preparation will comply the limit test of arsenic. So this is all about limit test of arsenic. Now, today's very important limit test is limit test of heavy metal. Now, the presence of heavy metal as an impurity, it is nothing but the limit test of heavy metal is designed to determine the content of metallic impurities. They are present in the pharmaceutical preparations. And these metallic impurities are colored by hydrogen sulfide gas. So, those heavy metals which are present as an impurity in the pharmaceutical substances, they are reacting with the hydrogen sulfide gas in acidic medium. In acidic medium, this hydrogen sulfide gas will react with those all metal impurities and it will give the brownish color solution. So this brownish color formation with that of the heavy metals is nothing but the determining parameter for the presence of heavy metal in the pharmaceutical preparations. Now, for example, what type of heavy metals are actually present as an impurity in the pharmaceutical substances? So those are metal which responds to the test are lead, mercury, bismuth, arsenic, antimony, tin, cadmium, silver, copper and molybdenum. These are all the category of heavy metals present as an impurity in the pharmaceutical product. But before we'll move towards, out of this already we have designed a separate limit test for the determination of lead and for the determination of arsenic already. For arsenic, just now only we have discussed gadget test. We are going to determine the presence of arsenic or the limit of arsenic in those tests. Then with respect to the lead, we have already determined it is with the formation of complex with dithezone. So the metallic impurities in the substances, they are expressed of parts per million. So the usual limit as per Indian pharmacopoeia is, which is allowed, or the how much amount of allowed concentration of heavy metal impurity in the pharmaceutical substances, 20 ppm. Beyond this 20 ppm, presence of any heavy metal concentration in the pharmaceutical substance, it is may lead to the toxicity. So this, what is the reaction mechanism or principle behind to do the limit test of heavy metal? Now, simply this heavy metals, either it is reacting with the hydrogen sulfide gas or they may be reacting with the sodium sulfide to produce a brownish coloration, brownish colored heavy metal sulfide complex. And this heavy metal sulfide complex will give the brownish coloration by forming a sulfide complex with that heavy metal. Now, procedure which is to be followed for the determination of limit test of heavy metal. Now, basically, this limit test of heavy metal is categorized into 4 methods. See, up till now only we have seen only one procedure for the respective limit test. For chloride, for sulfate, for lead, for iron, for arsenic, only one procedure we are going to follow for the determination of presence of those impurities. But here, presence of heavy metal impurity in the pharmaceutical substance can be determined by different 4 methods. Now, what are those 4 different methods? They are categorized into method A, method B, method C, and method D. Now, what are the basic differences between all these methods? Why they have categorized all those 4 different methods for the determination of heavy metal presence in the pharmaceutical substance? So, our method number 1, that is method A, which is used for the substance which give clear colorless solution under specific condition. So, generally, So generally, method A, it is used for the substance which give clear colorless solution under specific conditions. So this is our method number 1 or method A. What is the meaning of the word, or what is to be performed in method B? What is method B? Method B belongs to, it is used for the substance which do not give clear colorless solution although we are going to follow specific condition. So method A, clear colorless solution. Method B will not give clear colorless solution after maintaining a specific condition also. What is the meaning of the word method C, or what is actually method C? Method C is used for the substance which give clear colorless solution in the presence of sodium hydroxide. And our last method, that is method D, will not have any specification, but it is totally different from the above three methods. So this is method A, production of clear colorless solution in specific condition. Method B will not produce clear colorless solution in specific condition also. Method C, production of clear colorless solution in the presence of sodium hydroxide. And method D, it is totally different from all above the method. There is no any specific category, but they have given a different procedure. The procedure is quite different from above all three methods. That's why the method 4 or method D is categorized separately. So we will discuss one by one individual methods. That is method A. Now, what is the meaning of the word method A? Method A is used for the substance which give clear colorless solution under specific condition. Now, what type of procedure or what procedure we are going to follow for the determination of heavy metal impurity by method A? So solution is prepared as per the procedure which is specified in the monograph. That is 25 ml is transferred in the Nessler cylinder. See here again, here we are going to use Nessler cylinder for the procedure, and in case of standard solution, we are going to take 2 ml quantity of standard which is diluted up to 25 ml. So in both the test and sample standard solution, we have up till now filled our Nessler cylinder with a 25 ml volume. Now, later on, we are going to adjust the pH of both the solutions by 3 to 4 by adding dilute acetic acid or dilute ammonia solution. So, we have to maintain the pH of the solution between 3 to 4 by either adding acetic acid or ammonia solution. Later on, we are going to add uh, water to make up the volume up to 35 ml. So after making the volume up to 35 ml, we are going to add 10 ml of hydrogen sulfide solution. Now this hydrogen sulfide solution, it is prepared in the laboratory for the purpose of this heavy metal determination. So this 10 ml hydrogen sulfide solution we are going to add in the uh, both a test sample as well as standard sample. Now again we are going to keep it aside both the Nessler cylinder for 5 minutes, and then we are going to compare the color intensities produced in the test sample solution with that of the standard solution. The color produced in the sample solution should not be greater than the color produced in the test solution will not be greater than the standard solution. Then and then only our test sample will comply the limit test of heavy metal prescribed by method A according to Indian Pharmacopoeia. So this is method A. What is actually a method B? So with respect to method A, production of clear colorless solution in specific condition. Now what specific condition we have maintained here? We have maintained a pH which is approximately 3 to 4 throughout the reaction. And this pH we have maintained by using either acetic acid or ammonia solution. By adding both of these solutions, we have maintained the pH of the solution by 3 to 4. Now, method B will not specifically give the clear colorless solution after conveying the specific conditions also. Now, what is the procedure for method B for the heavy metal limit test? So, we are going to weigh a specific quantity of the substance which is moist with the sulfuric acid and ignite on a low flame till it is completely charred. Then we are going to add a few drops of nitric acid and heat to 500 degrees centigrade. So after charring of this compound, we are going to add nitric acid and heat this compound up to 500 degrees centigrade. Allow to cool, add 4 ml of hydrochloric acid and evaporate to dryness. Moisten the residue with a 10 ml of hydrochloric acid and digest for few minutes. Neutralized with ammonia solution. Make just acid with the acetic acid. So we have to maintain the pH of the solution with the 3 to 4. Then in case of standard solution, take 2 ml of standard layer solution and dilute it up to 25 ml with water. Then adjust the pH between 3 to 4 by either using acetic acid or ammonia solution as like that of previous method A. Then dilute the volume up to 35 ml, add freshly prepared 10 ml of hydrogen sulfide glass, make up the volume up to 50 ml, keep it aside for 5 minutes and then compare the result produced by the test solution with that of the standard solution. Now, every time the instruction is given on this table that view downward over a white substance. So here there is formation of a small amount of precipitate is there. So we are going to compare the results of this against white background. Then observation, if the color intensity produced in the test solution, if it is less than that of standard, then only our sample will pass the limit test method B for the heavy metals. Now, limit test of heavy metal by method C. Now, what is actually a method C? It is used for the substance which give clear colorless solution in sodium hydroxide solution. In method A, specific condition, clear solution. Method B, no clear solution in specific condition also. Then in method C, a clear colored solution in the presence of sodium hydroxide. So here also a sample solution is filled in the Nessler cylinder. In case of standard solution, 2 ml of standard lead solution, that is heavy metal. Then make up the volume up to 50 ml. Then add 5 drops of sodium sulfide in both the tests. Mix and set aside for 5 minutes for the formation of color intensity product. Now after that, after formation of color intensity product, we are going to compare the result produced in the test solution with that of the standard solution. And if the color intensity produced in the test solution is less than that of standard, then only our sample will pass the limit test of heavy metal. So only here the change in the previous method is we are going to use sodium hydroxide solution in the sample solution. Now what is the procedure difference? Solution is prepared as per the monograph, that is 25 ml is transferred in the Nessler cylinder, or weighed amount of the substance is dissolved in 20 ml of water, and to it we are going to add 5 ml of dilute sodium hydroxide solution. That means the sodium hydroxide solution will solubilize the another impurities or the impurities which are present in the test sample. So only that much difference is there when we are going to compare the results, or when we are going to compare the different methods used for the preparation of heavy metals. Then our last method for the determination of heavy method is heavy metal limit test is method D. So it is not any specific, but only different type of solutions we are going to use as compared to the another three methods. Now watch what procedure we are going to actually follow for the determination of heavy metal. So here we are going to add 2 ml of acetate buffer in both the Nestler cylinder, that is test as well as standard. So in both the Nestler cylinder, there is addition of 2 ml of acetate buffer, pH 3.5 to each and above Nestler cylinder. Mix and add 1.2 ml of thiacetamide reagent and allow to stand for 2 minutes. Then compare the color by weaving vertically downward over a white surface. So the color produced with the test solution is not more than the standard, then our sample solution will pass the limit test of heavy metal. Now what is the actually difference, or what type of reagents, what type of samples we are using in case of method D? The method D's test sample is prepared as directed in the individual monograph and pipette 12 ml into a small Nestler cylinder as a test solution. But the standard solution, it is prepared by pipetting out 10 ml of either standard lead solution or standard lead solution containing uh, 2 ppm into the small Nestler cylinder, which is labeled as a standard, and to it add 2 ml of test solution and mix. So here only the procedure for the preparation of test and standard solutions are different. Rest of this procedure we are going to do commonly for both test sample as well as standard sample. Only the procedure difference is there while preparing the chemicals. So depending upon that, these procedures, they will give, if the color intensity produced in the test is less than that of standard, then our sample will passes the limit test of heavy metal. So this is all about the